everyone, welcome back to Math Online. I'm Mr. Solis, and on today's video we will learn about tangent ratios. So today's objective is students will be able to use the side lanes of a right triangle to find the tangent ratio. Just a quick review, a ratio is literally just a fraction. We talked about that in the previous video. So a ratio is a fraction. You need two numbers, numerator and denominator. In other words, the number at the top and the number on the bottom of the fraction. All right, with that in mind, keep in mind we only need two sides to create a ratio. A triangle has three sides. All we need is two sides. So with that in mind, let's move on to the next slide. All right, vocabulary. First term, trigonometric ratio is a ratio of the lengths of two sides in a right triangle. So in order to create a ratio, all we need is two sides of the triangle. Okay, there's actually three trigonometric ratios, but we are only talking about tangent ratios today. Okay, so now there's three scenarios, like I said earlier. First of all, we could pick these two sides, side length 40, side length 30, or we could choose side length 40, side length 50, or we could have said side length 30 and side length 50. So these are the three different types of combinations, but on today's video, we're only talking about tangent ratio, so we're going to actually focus on these two sides, right? Notice there's the longer side and the two shorter legs, right? The two shorter lanes. So those are the ones that we're going to focus. They have specific names, and we'll discuss that on the next slide. So first of all, the tangent ratio is a trigonometric ratio for acute angles that involves the lengths of the legs of a right triangle. And like I said earlier, we just need two sides to create the tangent ratio. All right, tangent ratio. So here's how it works. First of all, we have a right triangle here. We know this is a right triangle because we see this little box. The little box indicates that this angle measures 90 degrees. Okay, that's important. So there's two things that you need to worry about: the 90-degree angle and the angle of interest. Okay, so that's all we need to worry about. The 90-degree angle and the 90-degree angle, I should say, the 90-degree angle and the angle of interest. Okay, those are the only two angles that we need to worry about. Okay, nothing else. But of course, I will show you how to label all the sides of the triangle. Every side has a specific name. So the longest side of a right triangle is called the hypotenuse. Okay, so you will always find the hypotenuse across the 90-degree angle. Okay, so there's hypotenuse. I'm going to abbreviate with little h. Okay, from here on. So across the 90-degree angle, you will always find the hypotenuse. Now, that's the first one. Boom, check. Second one is the angle of interest. So they'll give you a tangent angle. So tangent of angle A, tangent of angle B, tangent of angle C, etc. Right? So in this case, they said, hey, I need you to find the tangent of angle A. So the ratio of tangent of angle A, right? So therefore, what we're going to say is, okay, well, if our angle of interest is angle A, I'm going to circle it in blue. All right, this is the angle of interest because that's what they gave us. Hey, we're looking for angle A, right? So across the angle of interest, this works all the time, guys. Here it is. Please listen. Across the angle of interest, you will always find, always find the opposite side. Okay, so let's label this with the word opposite really quick, and we're gonna label this. We're gonna actually abbreviate this with the letter O. Okay, so I'm gonna use O instead of the entire word opposite. So opposite, O for opposite. Got it? All right. Now we have two sides with a specific name: the hypotenuse, which is across the 90-degree angle, and we have the opposite side, which is across the angle of interest. Got it? All right. Now we have another leg, another side that has no name yet. Well, that side that has no name, we're going to call that the adjacent side. So we're going to call this adjacent side. Okay, and we're going to abbreviate this with the letter A, lowercase letter A. Okay, so let me see how my letter A comes out. Whoops, I'm going to use a different color though. Just keep in mind that I'm using the mouse to write on the smartboard, so it's a little tricky to do this. So there it is. Oh, kind of perfect. Awesome. All right, so those are the two things that you need to know. So let's put a little check. Okay. We need to know where's the 90-degree angle and what's across of it. We need to know where the angle of interest is at and what's across of the angle of interest. So here's the thing. Tangent of angle A has a ratio, right, with numbers. But in general, this will always be true. The tangent of angle A is equal to this specific ratio. You will always have the opposite length on the top, and you will always have the adjacent length on the bottom. Okay, so there will be numbers instead of letters. Okay, so tangent of angle A equals the length of the opposite side over the length of the adjacent side. Okay, all right, so let's keep this in mind. If you need to go back, please once again hit repeat. Not repeat, but watch the video again. So if you need to see this again, if you didn't quite get it, please watch the video again. All right, let's move on to the next slide. All right, so find the value of each trigonometric ratio. So in this case, they ask us, find tangent of x. So we want to know what the ratio of tangent of x is. So just keep in mind, we need, I'll write it up here, we need to identify where is the 90-degree angle and where is the angle of interest, right? So those are the two things that we need to find on the right triangle. So first of all, where is that little box? Oh, there it is. There's the little box. This little box represents 90 degrees. So across the 90-degree angle, we will always find what side? What do we call that? Hypotenuse, right? That's the hypotenuse. There it is for H. So the length of the hypotenuse is 50 units. Now, the next thing that we need to find, let me check off, is the angle of interest. Where do we find the angle of interest? Oh, on our problem. Do you see that? Tangent of what? Tangent of what? Oh, tangent of x. So therefore, our main focus is x. Where's angle x here on the right triangle? Oh, there it is. Boom. So this is the angle x. So across the angle of interest, this is the angle of interest, right? So across the angle of interest, we will always find what side? What do we call that side? Oh, it starts with an O. Opposite. Great. Awesome. Whoops, that's a horrible O, guys. Well, let's redo that. All right. Okay, there it is. Okay, so that's the opposite side. That's what we call that. Great. Now, the side that has no name, we should know that if we have the hypotenuse, we have the opposite side. The next side should be known as the adjacent side by default. Okay. All right, great. Therefore, opposite, hypotenuse, adjacent. All we need is, for a tangent ratio, the opposite side and the adjacent. That's all we need. We talked about this. For tangent of angle x, all we need is the opposite side over the adjacent side. That's all we need, guys. So here we go. Let's write our answer. Tangent of angle x is equal to what ratio? The measurement of the opposite side is 30 units over the measurement, or the length, I should say, the length of the adjacent side, which is 40. There it is. That looks like a 40 now. Boom. There it is. So that should be our answer. Tangent of x is equal to 30 over 40. But there's a problem. Oh, we need to reduce this fraction, right? So in order to reduce this fraction, we need to find the greatest common factor. And the greatest common factor between 30 and 40 is 10. So therefore, in order to reduce this fraction, we need to divide, right? We need to divide the top number by 10 and the bottom number by 10. Okay, so if we do that, we'll say tangent of x is equal to, what's 30 divided by 10? Did I hear a 3? Yay, 3, awesome, guys. Over, what's 40 divided by 10? Did I hear a 4? Yay, awesome, guys. So there it is. Our answer is tangent of x is equal to 3 over 4. Remember, this is not tan, it's tangent. Awesome. All right, so that's our answer. If you didn't quite understand this, please watch the video again, okay? All right, just remember, the greatest common factor in this case was 10. That's what we divided by 10 on the bottom and on the top of the fraction. All right, moving on to the next scenario. All right, so another example. Here it is. If you quite understand this or you want to try this before seeing the answer, please stop the video and try it on your own. Challenge yourself. If you get something else, no big deal. Redo it again, okay? So let's work this out now. So tangent of z. First of all, two things that we need to identify and know. Where is the 90-degree angle? First, that's the first thing we need to identify. Next, we need to find out what is the angle of, the angle of interest. Okay, those are the two things that we need to look for. First of all, I need to look for the 90-degree angle. Where is it at? Oh, is it this one? Is it that one? That one? No, it's the one with the box, the y. So in this case, the y is the 90-degree angle. So across this 90-degree angle, we will always find what side? What do we call that side? Oh, the hypotenuse, which is the longest side of the right triangle. Awesome. Good. Now, that has been checked off. Now we need to find the angle of interest. The angle of interest will always be given in your problem. So if you go back, this is problem 2, tangent of angle z, or tangent of z, right? So this is the angle of interest. It will always be given to you guys, okay? So if this is the angle of interest, across the angle of interest, we always find what side? Opposite side. Awesome. It's always the opposite side, guys. All right? So now we know the hypotenuse. We know what the opposite side is. So therefore, by default, the remaining side should be known as the adjacent side. And for today's ratio, all we need is the opposite side and the adjacent side for tangent ratios, right? So once again, for tangent ratios, or tangent of z in this case, right? All we need is the opposite side over the adjacent side. That's all you need. But in this case, of course, we need our answer. We need to substitute these values, right? So tangent of z is equal to, what is the length of the opposite side? Oh, 32 units, right? Over, what is the length of the adjacent side? Oh, adjacent side is here, it's 24 units. So 24. Now, this would be our answer, but we have to reduce our fraction. So we need to find the greatest common factor, and the greatest common factor of 32 and 24 should be, did somebody say that? Oh, it should be 8, right, guys? All right, hopefully you guys remember how to find the greatest common factor. If not, shoot me an email or something and I'll show you guys, okay? Just to review on that. So the greatest common factor between 32 and 24 is 8. Therefore, we need to divide both of these numbers by 8. So when you do that, tangent of angle Z is equal to, divide 32 by 8, and we should get 4. Great, guys. Awesome. Now divide 24 by 8, and we get 3. Perfect. Awesome. Amazing. So there it is. Tangent of Z is equal to 4 over 3. Sorry for this handwriting, guys. Like I said, I'm using the mouse, so, you know, I'll try to do my best. So there it is. If you guys have any questions, please let me know. Remember to subscribe to this channel for more videos. And if you enjoyed the video, please hit the like button. And remember, we teach a new lesson like this one almost every single day. I'm Mr. Solis, and I'll see you on the next one.